In this video, we will solve this polynomial inequality, and we will use interval notation to do it. Well, the first thing we're going to do is treat this like it was an equation and solve that for the border points. So if I have x to the third power plus x equals x plus 1, first thing I would do is I would get everything on one side by subtracting x from both sides. Wow, those are both x's. Okay, so subtracting x from both sides and subtracting 1 from both sides. Now these x's are going to cancel out. So that's going to give me x to the third power minus 1 is equal to 0. Now I'm going to solve this by factoring. Now I'm noticing that this is the difference of two cubes. That was a special case that we learned a long time ago. This always factors as a binomial and then a trinomial. The binomial is just the cube root of these two, so I'm just going to have x minus 1. Now the trinomial, if I take these and I square them, x squared and positive 1, that gives me the beginning and end. Now if I multiply these together, I get the middle, so 1 times x is just x. However, it's the opposite sign, so if this is negative, then this will be positive. So that's how you would factor this. Now, I will get the actual solutions by setting each one of these equal to 0. But when you factor the sum or difference of two cubes, the solutions from this part will always be imaginary. Alright, so they are not going to show up on our number line. So it's really just all about setting x minus 1 equal to 0. So we really don't need to go through the process of this won't factor. We'd have to do the quadratic formula. We get imaginary solutions. So don't waste your time. Setting this equal to 0 gives us x equals 1. So this is our only border point. So we're going to use that and put it on this number line. So there it is. Now I need test values in each zone, one on the left and one on the right. To the left of 1 is 0. So I will use 0 as one of my test values. To the right of 1 is 2. So those will be my test values. Okay. Now the border point itself is going to be a closed circle. Because we're dealing with less than or equal to, the border point is where it's equal to 0. So we're going to go ahead and include that by making it a closed circle. If it was just less than or just greater than without the equal to sign underneath, then we would have used an open circle. Okay, so keep in mind that in reality we're looking for where the function is less than or equal to 0. Let's use our TI-30XS multiview to help us out. So typing this in, x to the third power minus 1, so x to the third power minus 1. Okay, and for this activity, I like to have the calculator in ask mode. Okay, because that way I can put in any value that I want without any scrolling. So my two test values are 0 and 2. So I can just type them both in. So 0 and 2. Wonder if I can clear this one. Nope. Okay, so I just wanted to clean that up. So I have 0 and 2. At 0, I have a value of -1. At 2, I have a value of 7. Okay, so I have -1 and I have 7. Now the question is the function less than or equal to 0? So is -1 less than or equal to 0? Well, yes it is. Alright, all negative numbers are less than 0. Is 7 less than or equal to 0? Well, of course not. 7 is greater than 0. So the yes tells us that this is where the solutions are. So we will go ahead and draw a ray going to the left, indicating the solutions. But ultimately we need to write our answers in interval notation. So looking at this arrow, we have solutions coming in from -infinity to 1. So the final answer is going to be -infinity to 1. Okay, so they're using this brace instead of a square bracket, but I think that they mean for these to be square brackets. So with that in mind, then the answer is A. Notice the only difference between A and B is that B definitely has the round parentheses, and you want the square bracket. For some reason this software used the brace, but let's go ahead and turn those into square brackets.